All right, we're going to try some problems here on page 691, number 3 here. First of all, we're just, here are some of the basic formulas for angles and their arcs. An inscribed angle, which is literally on the circle itself, is equal to half the arc that it intercepts. If the angle is inside the circle, it's 1/2 arc, this should be plus arc. And if it's outside the circle, the angle is 1/2 arc minus arc. All right, let's take a look, see at this picture here, number 3. We have an outside angle, so we're going to use this formula right here. You can see at angle 50 here. Angle 50 hits, if I extend the lines, you will see that it hits this 160 arc, and it also hits this X. Now, sometimes we try to figure out the outside angle. In this case, they give us that, and we're basically going to figure out the unknown arc. So we're going to have basically the angle outside is 1/2. Because it's outside, it's going to be arc minus arc. Again, we have the angle 50, and we're going to kind of work this problem backwards. We have arc 160 minus unknown arc X. And this is the problem we're going to solve. Let's get rid of the half by multiplying by 2. Cancel, cancel. This is 100 is equal to 160 minus X minus the 160. You got 100 minus the bigger number. You got negative 60. And then it turns into positive 60. So arc X is positive 60. Now I'm going to deal with angle Y. Now angle Y is literally on the circle. So it's an inscribed angle. So we're going to use this one here. It is half the arc that it hits, and it hits this arc right here. So we've got to figure out what this arc is right here. The way we do this, we know this is 60 degrees here. This is now 60-degree arc. And we know that the entire circle is 360. So the first thing we're going to do is figure out the measurement of the green arc here. And so we would go, and a complete circle is 360. We're going to minus out 160, and we're going to minus out this 60, and we will get 140. And so angle Y, because it's an inscribed angle, is going to be 1/2 of the arc it hits, 140. So angle Y is 70 degrees. Okay? Different formulas for where the location of the angle is in comparison to the arc. Number 3. Okay, we're going to do number 5 here. We've got an interesting picture. There's a lot of lines here. Here are the basic formulas. We're going to figure out angle X here. And angle X, obviously, is inside the circle, excuse me. So we're going to use this formula for angle X. It is going to be 1/2 arc times arc. Now, if you look at angle X, and I'll just kind of draw it separately here, angle X, and only angle X, is right here. It hits this arc and this arc here. This arc, because it passes through the middle, is half the circle, 180 degrees. So this was half the circle. This is 60. This is 70. This portion here is the other half of the circle. So 180 minus 70 minus 60, this is 50 degrees. Okay? So now to figure out angle X, which is inside, I'm going to say angle X, the inside angle, is equal to 1/2 arc 180 plus arc 50. And if I do this correctly, it will be 115. 115 is angle X. Now, this is not an angle here for Y, this is an arc. But if you look at the Y value, I'm going to kind of redraw this picture here. We have an outside angle, and that angle is 53 degrees. We have this arc that the 53 hits, and this arc here, which is arc Y. This right here is half the circle. So this is 180 degrees. So we're going to use the outside angle. The outside angle is equal to 1/2 arc minus arc, but this one we're going to work backwards because we actually had the angle on the outside, which is 53, is equal to 1/2 arc 180 minus Y. Let's multiply by 2 here to get rid of this half. Multiply by 2, you get 106 is equal to 180 minus the 180, you get negative 74 for negative y, and then positive y is equal to positive 74. Now that's an arc. That is arc y there. And this is how you do number 5. Okay, we're going to do number 6 here. We got a really interesting picture here. You have like this star here, and you have no numbers. We have to figure out angle y and angle x. We obviously notice that angle y is on the circle, so that it is an inscribed angle. And angle y hits, if I extend the lines here for angle y with the pencil, it hits this arc here. So I got to figure out this arc here to here. But unfortunately, we don't have any numbers. But what we do have are tick marks. 1, 2, 3, 4, 5. And all 5 tick marks make a complete circle, which of course is 360. So 360 divided by 5 is 72 degrees. So each one of these tick marks is 72. 72, 72, 72, 72, adds up to 360. So for angle y, it is an inscribed angle because it's on the circle. It's 1/2 the arc that it hits. Well, the arc that it hits is 72 plus 72, which is 144. So 1/2 of 144 goes back to 72. And that's it. Angle y. Angle x is, if you'll notice, this one's way more confusing looking, and so you really got to stay focused in on where x is. I'm going to try to redraw it. Angle x, the star is going to throw people off, but if you just look at angle x, it's right here. And angle x is an inside angle, so we're going to use this formula here. It hits 2 arcs. It hits this one here and this one here. Hits this arc here, and if I extend the lines, it hits this arc here. This is 72 degrees. This is 144. I've tried to get rid of all the other distractions here and just focused in on angle x here, which hits the 72, and it hits the 144. So inside angle x is equal to 1/2 arc plus arc. And if you do this correctly, you will get 108. That's number 6.